So the thing we have to realize is that the derivative of a function is also a function. I'm using the notation here, y prime, f prime of x, or dy over dx. Keep in mind, y is the dependent variable. X is the independent variable. And we always take the derivative of the dependent variable with respect to the independent variable. So here, this is the derivative of y with respect to x. If you look at that, we can say derivative of f of x with respect to, sometimes we write with respect to as w dot r dot t, with respect to x. So here, one thing that we've got to realize is that the derivative of a function is also a function, which is why we denote it as f prime of x. Now you may say, I take the derivative of a line, 3x minus 8. I believe I used this example in the previous problem. And the derivative, in the previous video, the derivative is 3. And you may say, 3 is not a function, it is a number. But if you think about it carefully, this is simply a horizontal line. This is a horizontal line passing through y equals 3. And that is a function. So any derivative of a function, may it be the first, second, and the third, I'm going to talk about that below, is also a function. So what are higher order derivatives? Now we know y prime is dy over dx, which is f prime of x, where we have y equals f of x. Y is the dependent variable and x is the independent variable. This is what we call the first derivative of f of x, or y. Now, y double prime is d squared y over dx squared. We write it as f double prime of x. This is the second derivative of f of x, which simply is the first derivative of f prime of x. In other words, you take the derivative of f prime of x. F triple prime would be denoted that sort, and that would be f triple prime of x. That is the third derivative of the original function. And it is equal to the first derivative of the second derivative of the function. We can keep on going all the way up to the nth derivative. We denote it in that manner. So that simply means you take the derivative of f of x n times. So you keep on taking the derivative over and over again. So I already mentioned this in the previous part, but I'll explain again. First, we've got to find the derivative of 3x minus 8, and we are going to use the difference quotient approach still. So f prime of x would be equal to limit h approaches 0, f of x plus h minus f of x divided by h. So we have 3 times x plus h minus 8 minus 3x minus 8 divided by h. So we have 3x plus 3h minus 8 minus 3x minus 8 divided by h. Limit h approaches 0, 3x minus 8 plus 3h minus 3x minus 8 divided by h. So those two would go away. We simply have h approaches 0, 3h over h. The h's would go away. You get 3. Well, is that a function? Yes. F prime of x equals 3 is a function, and it simply is a horizontal line. Let's verify this by graphing. Some of you might know this, but if you can't visualize it, you can use the calculator. And let's go ahead and do y equals 3 and just graph. And you can see that it is a function. So here is another case. F of s is equal to s squared plus 2. What is the independent variable? The independent variable is s, and I'll call y equals f of s. So the dependent variable is y, and we take the derivative of y with respect to s. We can call it as f prime of s. We always take the derivative of the dependent variable with respect to the independent variable. So limit h approaches 0, f of s plus h minus f of s divided by h. Replace all the s by s plus h squared, s plus h. Plus 2 minus s squared plus 2 divided by h. I could FOIL the numerator. I'd have s squared plus h squared plus 2 times s times h plus 2 minus s squared plus 2 divided by h. A little bit of rearranging. If I write it as s squared plus 2 plus h squared plus 2sh minus s squared plus 2 divided by h, those two would go away. I have a h in common in the numerator, so if I pull that out, I have h plus 2s divided by h. The h's would go away, and I have limit h approaching 0, h plus 2s. If I apply the limit, the h is going to go away to 0. I'll simply have 2s. Is that a function? So we have found f prime of s equals 2 times s. Is that a function? Yes. It's a linear function. It is a line. So the calculator doesn't have the letter s, so I'm just going to use x instead. So the derivative we found is 2x. So if you graph it, you get a function. So the derivative of a function, again, is a function. So here we have x cubed minus 1. First we want to find the derivative, then we have to find the second derivative and determine if the second derivative is a function. We already know the first derivative of a function is a function. Now we'd like to know if it is true for the second derivative also. So let's start with the first derivative. Y is the dependent variable, x is the independent variable. So y prime, using the difference quotient, is f of x plus h minus f of x divided by h, limit h approaches 0, x plus h cubed minus 1 minus x cubed minus 1 divided by h. So we have to FOIL. If you FOIL x plus h cubed, you will get x cubed plus 3xh squared plus 3x squared h plus h cubed minus 1 minus x cubed minus 1 divided by h. So I want you to try this. So x plus h cubed is simply x plus h times x plus h times x plus h. If you FOIL and simplify, it is going to equal to that over there. I'm going to do a bit of rearranging. X cubed minus 1 plus 3xh squared plus 3x squared h plus h cubed minus x cubed minus 1 divided by h. Those two would go away. We have limit h approaches 0, 3xh squared plus 3x squared h plus h cubed divided by h. There is a h in common in the numerator. So if I pull that out, I have 3xh plus 3x squared plus h squared divided by h. Get rid of the h's. And if we apply the limit, we have 0 because the first term is going to go away because h is approaching 0. So the first term would become 0 as there is a h there. Second term doesn't change. The third term is 0 squared. So the first derivative is 3x squared. Is it a function? Well, let's graph it. Well, that is a function. It is a parabola. So as we have seen thus far, the first derivative of a function is a function. Now, how do we find the second derivative? The second derivative is the derivative of the first derivative. So we have to treat 3x squared as our function now. So let me call g of x to be the first derivative of the function, 3x squared. So the second derivative is limit h approaches 0, g of x plus h minus g of x divided by h. That would mean we have limit h approaches 0, 3 times x plus h squared minus 3x squared divided by h. If I FOIL x plus h squared, I'm going to get x squared plus 2xh plus h squared minus 3x squared divided by h. Distribute the 3, I will have 3x squared plus 6xh plus 3h squared minus 3x squared divided by h. So those two would go away, and we will have 6xh plus 3h squared divided by h. There is a h in common in the numerator, so let's pull that out. 6x plus 3h over h. h's would go away. Limit h approaches 0, 6x plus 3h. There is no h term in the first term 6x, so that will remain as is. The h in the second term is going to approach to 0, so we have 6x plus 0, so we get 6x. Is that a function? Well, let's see. It's a line, so the second derivative of a function is also a function. In general, the derivative doesn't matter if it's the first, the second, the third, the 10th. The derivative of a function is a function by definition. So here we have x squared plus 2, and we want to find the first derivative first. So limit h approaches 0, f of x plus h minus f of x divided by h. So that would be limit h approaches 0, x plus h squared plus 2 minus x squared plus 2 divided by h. Expand the first term, we will have x squared plus h squared plus 2xh plus 2 minus x squared plus 2 divided by h. So now we have limit h approaches 0. I'm going to do some rearranging. I'll have x squared plus 2 plus h squared plus 2xh minus x squared plus 2 divided by h. Those two would go away, and we'll have limit h approaches 0, h squared plus 2x h over h. There is a h in common, so if we pull that out, we have h plus 2x over h. Those two would get cancelled. Limit h approaches 0, h plus 2x. That would be 0 plus 2x. The answer is 2x. Is that a function? Absolutely. It is a line, so we know that from the previous problem. So it is a function. Let's look at the second derivative. The second derivative is simply the derivative of the first derivative. So I'm going to call the first derivative as g of x. So what we're trying to find here, using the difference quotient, limit h approaches 0, g of x plus h minus g of x divided by h. So that would be limit h approaches 0, 2 times x plus h minus 2x divided by h. So limit h approaches 0, 2x plus 2h minus 2x divided by h. Those two would go away. Limit h approaches 0, 2h over h. The h's would go away. Limit h approaches 0, 2, which is simply 2, because 2 is a constant and it is not affected by h. Is that a function? Yes, we have seen this previously. Y equals 2. This is simply, I'll call this function as h of x. No, I don't want to use that letter. P of x. So y equals 2 is a horizontal line passing through 2 in the y-axis. Let's find the derivative of that. So the third derivative is the derivative of the second derivative. So y triple prime, you could also write it as y raised to the power of 3 within parentheses. Limit h approaches 0, p of x plus h minus p of x divided by h. Well, what is p of x plus h? There is no x to replace in p, so it will simply be 2, and p of x is 2 divided by h. What is 2 minus 2? 0. 0 over h is 0, and we take the limit h approaches 0, and you get 0. Well, is the third derivative a function? Indeed, it is. So this is y equals 0, and y equals 0 is a line passing through the x-axis. Y equals 0. And it is the x-axis. By definition, if you draw a line through the x-axis, it still is a horizontal line. So the third derivative is also a function.